Hello, chemistry students. Welcome back. Today we're going to move into our discussion on solutions and how different solutes and solvents mix together. Let's get started. Make sure you've got your spiral notebook out. Take some good notes. Remember, these slides are posted for you. We'll do part 1 today and part 2 tomorrow. All right, so our objective today is going to be for you to be able to define a solution as a mixture in which one substance is dissolved in another. So let's get started. Solutions is a homogeneous mixture that has the same composition, color, density, and taste throughout. We go back to our earlier discussion on matter. We're dealing that with solids, but that would be a mixture, would be either a homogeneous mixture or a heterogeneous mixture. A solution is a homogeneous mixture. So everything has the same composition, color, density, and taste. There are 2 parts to a solution. The first is the solute. That's the substance that's going to get dissolved. So, for example, if you wanted to make some lemonade and you use lemonade powder or Kool-Aid, or you were using an iced tea powder to make something, that would be the solute. The solvent is the substance that's going to be doing the dissolving, and the solvent is usually a liquid. Together, you add the solute and the solvent, and they become a solution. So, solutions don't always have to be solids dissolved in liquids. Many times, you can also dissolve a liquid in a liquid. So, for example, gas. In gas, air also has oxygen and nitrogen. So you can have a solution that's a gas in a gas. When I do diving, we use some mixed gases, and we're going to make a solution of oxygen, nitrogen, and helium. And that's a gas solution. It's still a gas, but we call it a solution. Many times you can also put a gas in a liquid. If any of you have had any kind of soda pop recently, a Coca-Cola is made up of a caramelized liquid that has sugar and flavoring and water, and then carbon dioxide gas is introduced into that liquid to give it its fuzzy flavors. And you can also have a liquid in a liquid. There's a solution known as rubbing alcohol, and it's used to work on the skin, and that is a combination of water in alcohol together. So these are all solutions. You can have gas in gas, gas in liquid, and liquid in liquid. So it doesn't always have to be a solid going into a liquid to make a solution. Solutions can also be solids in solids. Now, if you remember the other day, we were talking about changes of state and how solids become liquids. Well, I can take 2 solids, add enough thermal energy to them to the point where they melt and become liquids, and then mix those liquids together in a solution. And that's how metal alloys are made. Alloys are solutions of metals dissolved in other metals. Aluminum alloys, steel alloys, copper and bronze alloys, gold alloys, silver alloys. Each metal is melted down to a liquid state, mixed, and then allowed to solidify again. And that's usually done in a fairly controlled environment, because how quickly it cools affects how that solution ends up being a solid. And so the metal bronze is actually a combination of copper and zinc. Copper and zinc are individual elements that you find on the periodic table. I believe copper is Cu and zinc is Zn. And so those two elements get melted down in a specific quantity, specific ratio, and they get mixed together to form a solution, and then they solidify back out to become bronze. Bronze is used a lot for casting, where that liquefied alloy is poured into a mold so it can come out. They're called bronze castings. Brass, that's made up of many door handles, musical instruments. Lots of things that are used on boats are made out of brass. Brass is a combination of copper and tin. Again, two individual elements heated to the point where they melt, then they become a solution, then they cool, and they become a new alloy because they started out as solutions. Sterling silver. If any of your grandparents have utensils for the table for fancy dinners, they have sterling silver. Sterling silver is a combination of copper and silver. Again, those are melted to the point where they liquefy. Those solutions are mixed together, cooled carefully, poured into molds to become that sterling silver. Now, solubility. Let's go back and remember from some physical properties. Solubility is the maximum amount of solute that can dissolve in a certain amount of solvent at a given temperature. And so, for example, if you took sugar and put 4 tablespoons of sugar into an 8-ounce glass of water, you'll see that only a certain amount of it will dissolve and the rest will sit on the bottom, because in that cold water, it can't dissolve any further. And so solubility is the amount of solute that can dissolve in a certain amount of solvent at a given temperature. And that's a substance's ability to dissolve. And it depends upon the nature of the solute and the nature of the solvent and the temperature. Those 3 things have an effect on solubility. Now, there are 3 types of solutions, and solubility results in those 3 different types of solutions. You can have an unsaturated solution, a saturated solution, and a supersaturated solution. And if we look at this illustration here, you'll see on the left under unsaturated, you only see a small amount of solute floating around in the liquid. So it hasn't fully saturated the amount that can be dissolved. In a saturated solution, you see that it is holding as much solute as can be dissolved. And a supersaturated solution, the image on the right, has so much solute that it can't dissolve all of it, that the rest of it just sits on the bottom. So let's look at that in a little bit more detail. Unsaturated solution is able to dissolve more solute at the given temperature. And it's not at its maximum capacity. You can keep on adding more and more until no more can dissolve. So an unsaturated solution is able to dissolve more solute at a given temperature. And each time a solution is heated to a higher temperature, it becomes unsaturated and more solute can be added. Now, a saturated solution contains all the solute it can hold at the given temperature. And the given temperature is whatever temperature you have decided that that solution needs to be at. And so right now, if you took out a glass of water and you took the water from the tap in your sink, it would be at room temperature. Actually, it'll probably be warmer than room temperature because here in Lake Havasu, all of our water pipes run all around the city, and outside your house right now is probably warmer than it is inside. And so at first that water is going to come out warm until it starts getting all the flow. But if you took water from your tap right now, let it run for a couple of minutes, and then put that in a glass, you'd probably have water that's somewhere in the vicinity, if we're dealing in Fahrenheit, maybe about 72 degrees Fahrenheit. And so the saturated solution contains all the solute that it can hold at that given temperature. And if you want to experiment with that on your own, just take out a glass of water, take out some sugar or salt, either one, and start off with a teaspoon of it and mix it in and keep going until no more can dissolve. And so saturated solution is at the maximum capacity at that given temperature. But if we raise that temperature, more solute can be dissolved, which moves us to the supersaturated solution. And a supersaturated solution contains more solute than it can hold at the given temperature. It contains more solute. If you look at the illustration here, you'll see that this solute sitting at the bottom has not dissolved yet. But if we raise the temperature, it may start to dissolve more. And so it's above the maximum capacity, but additional solute collects at the bottom of the solution until we raise the temperature. These solutions are considered unstable. And they're unstable because there's still solute that has not dissolved. So supersaturated solutions are unstable. Now, just like the other day when we were looking at state changes of matter from solid to liquid to gas, we dealt with a heat curve. Solutions work with what's known as a solubility curve. And a solubility curve is a data-based graph comparing the amount of solute that will dissolve in a given amount of solvent at various temperatures. And the most typical solubility curves are graphed based on solid and gaseous solutes that will dissolve in 100 grams of water. And it's a solute to solvent ratio. So let's take a look at that. So here we have a solubility curve that shows a different amount of solute a solvent can hold at different temperatures. Now, on the left-hand side, we're looking at grams per 100 grams of water, and that's your solubility level. And on the bottom, we're looking at the temperature of that solution. And so we have 4 chemical compounds here: potassium nitrate, sodium chlorate, potassium bromide, and sodium chloride. Sodium chloride, by the way, is salt. And so let's look at the sodium chloride. That's going to be the green line. And only looks like about 35 grams will dissolve in water, regardless of the temperature, from 0 to 100 degrees. However, if we look at potassium nitrate, as the temperature is increased on the water, more and more potassium nitrate can get dissolved in that solvent. And so you can actually dissolve as much as 240 grams of potassium nitrate in 100 grams of water, just by heating it up to 100 degrees Celsius. And so this is just a very simple way that chemists can determine how much solute they can add to a solvent when they're making solutions. So let's review solutions. A solution is a homogeneous mixture that has the same composition, color, density, and taste throughout. Now, it's very important that you don't taste solutions that are not foods. Okay? That goes back to our lab safety. And there are two parts to a solution. The solute, that's the substance that is being dissolved, and the solvent is the substance that is doing the dissolving. Remember, there are three types of solutions: unsaturated solution, saturated, and supersaturated. All right, we've covered a lot today. And what I'd like you to do now is to update your notes, open up the slides if you need them to get any of those graphs or tables. Then open up the assignment tab. There is a video in there that you watch, and then complete the questions. And in part 2 of solutions, we'll take a look at how dissolving actually works. So I'm going to stop my share right now. You guys are great today, and we'll see you next time. Have a great day.